Okay, so now that we have a grip on what the definitions are that we need to know, we're going to move into how to do an example. But first, we need to know how to do the steps. When someone asks you the stoichiometric measurement of something, they want to know how many moles of something you have relative to other substances, or how many grams that you have. We're going to do the one that requires moles first. Here are the 4 steps. Please make sure you write this down in your guided notes tracker. First, balance the equation. You have to balance the equation. That's how I would have it written in bright red, because without balancing, you won't know the relative proportion of reactants to products. Okay? Number 2, we have to determine the units of desired substances, right? The unit of the desired substance. What are they asking us to produce? What units? Moles, or do they want grams? That's important. 3, we use the mole ratio. The ratio is how many moles of one substance is related to the number of moles of the other substance. Like in our example, sodium, there was 1 mole to every 2 moles of chlorine. That is the mole ratio. Once we determine that, we can then use that mole ratio to number 4, to calculate, that's first. And this final step has a star. Only convert the moles to the desired unit if the equation asks for it. Okay, so if I know that I have to make my moles into grams, then I will need to go and find out how many grams there are in sodium, okay, using my periodic table. But in this example that we're going to do, we will not be doing number 4. But the second example, we will. So let's go through the steps as we say. So number 1, what is it? That's right, we have to balance that equation, so let's get to it. Here is an example of hydrolysis. Can anyone tell me what type of reaction hydrolysis is? It's just like it sounds, hydrolysis. It means water is broken up into its component parts, right? So we have H2O as our reactant, and then we have product, hydrogen gas, H2, plus oxygen gas, O2, okay? So when we have 1 starting reactant that breaks down into 2, this is a specific type of decomposition reaction, as we talked about before. And you are now an expert on how to identify different types of reactions. So first thing we're going to do is balance. So on this side, we have 2 oxygens, okay? But we only have 1 oxygen there. So the first thing I'm going to do is put a 2 in front of my water, right? 2 moles of H2O, okay? Now the oxygens are matched, 2 times oxygen and then 2 oxygens. But now I've affected the amount of hydrogens, because there are 2 hydrogens over here on the product side and only 2, and now there are 4, 2 times 2 is 4 hydrogens on the reactant side. So what do I have to do? Using multiplication of factors, I put a 2 in front of my hydrogen, and now we have a balanced equation. Check, check, okay? Number 2, determine the units of the desired substance. So what are we going to do? What we're going to do is I'm going to put some values in for the water, okay? Put some values in for water, okay? So if I have been given 0.5 moles of water, how much oxygen will be produced. So let's take a look at this question. What is it telling us? Because we need to determine what units is desired. What is desired? So we are given 0.5 moles of what? Water. So they tell us the number of moles of water that we have. And again, it's in the units of moles. But the question asks how much oxygen, okay? And so we would have to be specific. How many moles? We'd have to be specific, see? You gotta be careful. How many moles of oxygen will be produced? So let's look at the two things in question, water and oxygen. It did not make a reference to hydrogen, just oxygen and water, okay? Because remember, water went into producing both hydrogen and oxygen. So this question wants to know how many moles of oxygen will be produced if we start with 0.5 moles of H2O. So let's look at step 3, our mole ratio. Our mole ratio, okay, so first of all, number 2, we want our answer in moles. Check, okay? Number 3, we use our mole ratio, right? We use our mole ratio. And the ratio is for every 2 waters, there are 1, remember we said if we don't see anything in front of the molecule, then that means it's a 1 molar substance. So 1 mole of oxygen. So therefore it is a 2-to-1 relationship of moles of water and moles of oxygen, okay? So let's start with what we have here, okay? We are given, so now we need to calculate using dimensional analysis, right? So let's go for it, because here we are at the calculation phase. So the way we start out is what we have. We have 0.5 moles. I'm gonna write this in blue so you can see it. We have 0.5 moles of water. And actually put that so you don't mix up your relationship. And that is over just 1, right? Then we start out with something, we just have moles of H2O. Now, if we factor this mole ratio here, we have 2 moles of H2O relative to 1 oxygen. So which one do you think would go on the denominator? Because remember, we want these things to cancel out. And by cancel out, all we mean is that when they divide together, that they will equal 1, thereby canceling out. So it would make sense to put moles H2O on the bottom. So I take 2 H2O, 2 moles of H2O on the denominator, and then in the numerator, I put to 1 mole of O2. Now let's check. Let's make sure if that's what we're being asked. How many moles of oxygen? So that's exactly what we're being asked, so we're on the right track. Now, all you have to do at this point is look at what you have. The units cancel, and then we end up multiplying across, getting 0.5 moles, here's our units, of oxygen over 2. Okay. And so just by knowing that 0.5, half of 0.5 is what? Is going to be, come on, you can do it. You can do it. 0.25, right? So 0.25 moles of oxygen is our answer. And if you think about it, that makes sense, doesn't it? For every 2, there's half as many oxygen. So even without doing this relationship and this calculation, we could have just derived that 2-to-1 means that the other one is half the amount of the one in question. So there you have it. Now, I want you to try the next example. The next example is a very common one that you're familiar with, because when you did your PhET simulation, when you were going through balancing reactions, you were able to balance the reaction. But now we're going to put a question to it. The question is asking you here, okay, right? The question is asking you here, if you are given the reaction N2 plus H2, and you're given NH3, which is ammonia. This is one of the most common agricultural chemical reactions where we grow fertilizer for plants, okay? So if N2 and H2 yield NH3, I want you to then solve this problem. How many moles of N2 are necessary to produce 2 moles of NH3, okay, ammonia, okay? So I will leave it up to you to follow the same steps that we followed. So hit pause and take 3 minutes to work through the steps of this problem. Remember, write down your questions so that you can be prepared to ask them at the end, or email me if you get stuck.